Today is Saturday, September 17th, 2022. It is also day 426 of data science. And today I'm going to be working through this worksheet that I got from StatsMedic with Python. So the idea is we're trying to predict how many iPhone 8s will be sold. And so what StatsMedic did was they took previous data from, previous sales data from Apple, and this is what it looks like, right, at the right here. And they're just going to, well, at least we are going to use this data to find the line of best fit so that we can use that line to make predictions for the iPhone 8 and how many units will be sold specifically for the iPhone 8. And so that's kind of the idea, and I downloaded the PDF from here. This is actually the lesson plan, either one of these, the AP Stats, CED, or the Classic. I just know that it's Unit 2, Day 5. I downloaded that. I downloaded the answer key also so that I could, make sure I'm right as I'm going through it. And so here I am in Python. So the first thing to do is to convert this data into a Pandas data frame, right? So to do that, I'm going to use Adobe's PDF to Excel conversion. So I'm going to select a file, and for me, that's going to be this one over here. It's the same file as the right here. So I'm going to export that and wait for a few seconds, and I'm going to download it up here, and then I'm going to go back over here to my data frame, and I'm going to open up the Excel file and just wait until it opens. Okay, so this is what it's looking like. So it's literally the PDF in Excel. What I really want is just this data here. So what I'll do is I'll select this and I'll just copy it, and then I'll create a new file at the bottom here. Oh, make sure I enable editing. Create a new file, delete table 1, delete that, and then I'm just going to go here to A and just paste that in there. So I'm going to delete this B column, the C column, so right click delete, and then let's see, I think everything's fine. So at this point, just go to File, Save As, and I'll save it as an Excel file, it doesn't matter. So save that. And then I'll go into Python and I'll open up a new code snip and I'll import Pandas as PD. So Pandas is a library that I'm going to use to read in that data file. So after I run that, I'm going to create a data frame, so df, right, a variable. That's going to be my data frame, and I'm going to do pd dot, and I'm going to do read Excel because I'm reading in an Excel file. And then I'm going to put quotations, and I'm going to go to the folder and actually upload, upload that file into here, and then copy the path when I right click on the little colons and just paste that in there. And then if I run that and I do df, here's the data. Beautiful, right? So we have the iPhone, same thing that we have on the screen over here, we have in Python. And so now I can use this data to, work with it in Python. So that's the first step. So then, well, really, the first step to work with Python, but the first thing they ask us to do here in StatsMedic is to create a scatter plot of the data with year as the explanatory variable, and units sold as the response. So meaning the year is going to be X and the what is it? The units sold is Y. Okay, so to do that, there's another library called import. Well, no, it's not called import Seaborn. It's called Seaborn. Seaborn as SNS. There's also matplotlib, which is the main library, but I'm going to use Seaborn here, so I'm going to do sns.hisplot, nope, scatterplot. Is it scatter or is it scatterplot? We'll see if it gives us an error. And then really what we're plotting, again, is the year and the units sold. So I'm going to have to target those. So df is my x variable, so that's going to be the year, right? I'm using bracket notation, so I'm just putting the brackets and the name of the column that I want to plot from the data frame, right? And then the next one is, okay, data frame, and then again, the unit sold, which is going to be my y variable, and beautiful. So it is sns.scatterplot. So we can clearly see the data, or at least the scatterplot of data, and the year is an explanatory variable, so it's what explains the units sold, and this is, unit sold is the y variable. So it's number 2 is saying describe the form of the distribution. So we could say that you can see a slight curve. It's not exactly linear. Yeah. And then it says use the applet to find the least squares regression line, write the equation below. and graph it on your scatter plot above. So, okay, so there's another library. So from scipy dot stats, I think, no, actually I could do scipy from scipy import stats. And then I can do stats.linregress, and linregress is a function that outputs the, what'd you call it, the terms for the least squared regression line. So just to kind of sum things up or to do a summary, the least squared regression line looks like predicted y is equal to a plus bx, with x being my slope and a being my y-intercept. So really what we're looking for here is those values. So I'm looking for my y-intercept and my slope, and linregress in Python is what gives me those values. So I'll just go ahead and plot in the two things that I need, which is literally the x and y. So I'll just go ahead and copy this, paste that in here. Okay, run that. And here's what it returns to me. So it returns to me the slope, and it returns to me the intercept, and some other things that we don't really need to look at right now. So essentially, this is the equation. So predicted y. So in this case, in context, I'll actually write it in context later, but predicted y is equal to negative 3,222.6328 plus 1.605x. That is my least squares regression line. So that is the line of best fit in this case, right? So in context, what that says is the predicted, what is it called? Units sold? Units sold is equal to negative, is it negative? Oh wow, it is. 322.6328 plus 1.605 year. So, so when you put in the year, you'll get the predicted units sold for that year. So that's kind of the idea. And then let me just write the form here. So the form is curved. Use the least square regression line to calculate the residual for 2007. Interpret the residual. So again, the residual is A minus P. So it's the actual minus the predicted. So your actual value, let me go ahead and erase this. So sloppy. Let me redraw that. Okay, so your actual value is what, the true answer. So it's exactly how many units were sold in that year. And then the predicted is what your least squared regression line predicts, right? Whatever units were sold in that year. So the residual is the difference between those two. So it's saying for 2007. So really what it's asking us, it's telling us to plug in 2007 for X so that we can get the predicted units sold for 2007. So let's do that. So code. So really, let me actually just set it up here. So I'm going to say predicted units sold is going to be equal to, just a little quick tip here. If you ever just want to get, values, because this is what it returns. You can actually set these to their own variables. So for me, I would just do slope, put that in here, comma, intercept, comma, R value, comma, P value, comma, what's the other one? Standard, whatever that is, comma, and then the last one is the intercept of that one. All right, set that equal to that, and then what I can do now, let's see, not enough values to unpack. Did they not count this one? For some reason, it never counts that one. Okay, so then now I can just say, okay, the intercept, so it's going to be equal to that value here. And then what is it? Plus the slope times x. And then I'll have to say, actually, it's not x. I have to put it in context, so it's year. And so really, the year here is equal to 2007. So if I run this and then run that, and then I could just output, whoops, the answer here, I'll be able to get the predicted units sold for 2007, which doesn't really make sense because it's negative 1.3 whatever. Is this even right? Let me check my answer. Yeah, it is negative. So why do I have a negative why do I have a negative residual? Oh, oh yeah. Oops, that's Twitter. Ignore that. Okay. Um, oh yeah, okay, so it does make sense. Okay, so oh yeah, okay. Sorry, just thinking to myself. All right, so really the predicted units sold is negative 1.3978 units of, I guess, the original iPhone, because that's what we're looking at here in 2007. So really we're kind of testing our data. Um, so then it's asking us, okay, that is the predicted units sold for 2007, and it's asking us to calculate the residual. So, really, how right or how close we were to the actual answer. And we know the actual answer is 0.5. So, what we would do is, okay, I could just set up R, or like the residual, is equal to the actual value minus the predicted value. So, for me, actually, let me put residual here. So, it outputs. So let me set up the variables here. So let's start with the actual value. So the actual value is, let's see, is the data frame units sold, and it's the first value. So again, in Python, we start with 0, so the first one is technically 0. So if actually, let me just run that here so you can see that it's going to return to me 0.5. Right? 0.5, that is the actual value here. And then, or we could just literally put 0.5, but I like, being punctual just in case, data changes. You don't have to go and manually change it. It just changes for you. So that's just the idea. And then the residual, or at least the predicted, is going to be equal to my predicted units sold over here at the top. And then now it's actually going to give me the residual, which is 1.8978 rounded to the 4 decimal places. So essentially that's the residual. And what does that mean? So we can look at so it says interpret the residual, right? So was my prediction too high or too low? So the residual is 1.89, right? My actual answer was, what was it again? Negative. So actually, let me write it down. So this is kind of like the key to interpreting residuals. So if your residual is positive, that means that your prediction was too low. And if your residual was negative, that means that your prediction was too high. Because it makes sense, right? If you have your actual is greater than your predicted, you're going to get a positive answer, meaning your prediction was lower, right, than the actual, because the actual was higher. So that means you still got a positive answer, meaning your prediction was lower. So that's kind of happening in this case. My actual or the actual units sold were 0.5 million. And then my predicted value was what? Negative 0.39 or something. So that was negative 1 point, I'm going to say 1.4 million, right? So that's my residual. And so, oh, no, I'm sorry. That's my predicted. What am I saying? Okay, let me just erase that real quick. Okay, so the idea is that's my predicted, and then my actual was 0.5 million. And so, right, then that would be my residual. And so that's just 0.5 plus 1.4 million. And that obviously gave me a positive answer of 1.9 million. So really what that's saying is that my actual value or the actual value of units sold in 2007 was 1.9 million units more than what I predicted, meaning that my prediction was too low. So just to kind of write that down, let me write that down. All right, so I wrote it down. The actual number of units sold of the original iPhone in 2007 is 1.9 million more than our predicted value of negative 1.4 million. I probably should have added there. Let me just put a million. There we go. Let me just make sure I'm right. So, oh yeah, okay. We could say curved or nonlinear for number 2. Number 3, we're right. Number 4, negative 1.4, 1.9, we're right. Okay, let's move on. So the next thing is the residual plot, right? So it's saying graph the residuals on the axes below. This is called the residual plot. So let me just do the first one by hand, which we literally already did. So the predicted units number of sold was negative 1.4. So the residual again, so we got negative 1.4 and then the residual was 1.9. And so you just do that for the rest of them, or because the goal is to actually just plot the residual, I could just do SNS dot resid. It's either resid or resid plot and just literally take in the two columns that I want to find the residual for, and that would be the year and the units sold, right? So paste that in there, run that, resid plot, oops, plot. Why does it keep doing that? Okay, I'm just trying to select here. Okay, plot, run that. Beautiful. That's the residual plot. So just to plot the first one, in 2007, 1.9 is like over here, right? And that's literally what we see. And then, you just have the rest of them. Let me just kind of figure out their values. So again, it's 0.2. So this is how to do it by hand, right? You just do what I just did in number 4. Um, so 1.8, negative 0.8, 3.4, negative 1.7, and so on and so on. And then you just plot those, or you could just use Python and do it there. So it kind of looks like that. I'm really just gonna copy this image. Oh, I can't do that here, can I? No, I have to do it. I used to do this with whiteboard and I can just paste the image in there. Well, yeah, this is kind of the idea though. That's a residual plot. And so now in number 7, it says for which points was the actual greater than the predicted. Um, so we could just see that in the graph. So whichever ones are positive are the ones that, were actually greater than the predicted value. Or let me just check. So it's asking for which points was the actual value greater than the predicted. So in this case, our actual value was greater than the predicted. And so that means it was a positive, so that means it's above, right? So just double checking. So yeah. So any points that are above, right? That have a positive value means that the actual value was actually greater than what the predicted value was. Um, so for me, that would end up being what, 2000, 2007, 2008, 2013, 2014, and 2015. And then we can see that, so 2008, 0.2. Oh wait, no, it was 1 is definitely greater than 0.2. 2000, let's see, 2013, I don't have that. Let me look at it. So 2013, 9 was the actual, and then 8.2. So 9 is greater than 8.2. So that's just kind of proving that idea there. So again, the idea is when they ask you this, okay, just if your actual is greater than predicted when your actual, nope, when your residual, let me see, when your residual is positive, and then your actual is less than your predicted value, or probably should do this in terms of predicted value. So your predicted value is less than, yeah, whatever, you do the math. When the residual is negative, so in other words, above the line, below the line. Okay. Okay, and then it's asking, do you think the regression line is a good fit for the data? Why or why not? Explain using the residual plot. Okay, before getting into it, I just wanted to kind of explain a little bit more of the residual plot. So this right here is 0, like this line. So this graph is just graphing the difference between your actual and your predicted values. And so usually the ideal difference is 0 because you want your predicted value, the predicted number of iPhones sold, to be really close to the actual value because that's the whole point. You want to use this line to, predict, the iPhone, how many iPhone 8s will be sold in whatever year that was. And then in order to do that, you want the difference between the predicted value and the actual value to be zero, because that means that you're really hitting on, you're hitting, I don't even know how to say it. You're hitting on the point, you're doing it right, okay? So because, it's never perfect, so 2007 your residual was really high, meaning, that your actual um was actually greater than your predicted value, right? Um, and so you had a higher difference, right? And so really you want your residual to be close to zero. And that's where this comes in. So your residual plot kind of tells you, hey, is the line that you just, use to predict these values, is it really the best line to use? Um, and so you can tell if it's not the best line, if it has a curved, if it has any pattern actually. If it has any pattern, it's not the best line. And number two, um, if okay, let me rephrase. It's going to be the best line if it has no pattern and the residuals are centered around zero. Again, that's where this comes from. You want your residuals to be closer to zero as they can be, right? Because you want there to be really no difference between your predicted value and the actual value. And right now, this is a thing called test and training. Like you have the data. So the whole purpose was to find, the iPhones that are going to be sold, the iPhone 8s, right? That are going to be sold, right, to find that predicted value. But we tested um, our line that we're using to predict those values with old data, with like the original, right, iPhone, and we found that the residual was actually very low, and that's the kind of the idea where this is coming from. So as you keep doing that for each of the data points, you're going to get, a lot of residuals, and they could either be higher or lower, and then they're going to become, a residual plot. And so then from there you can see, okay, is there a pattern and is it centered around zero? If there's no pattern, perfect. So a pattern could be curved, it could be exponential, whatever. If you see a pattern, which clearly we see here, we can see like a parabola, like a curved parabola here, that means that it's not a good uh that's not a good line. It's not the line of best fit, right? And then especially if we see that the values that the residuals are not centered around zero and they're very scattered, then that's not a good residual, because what it's saying is that the values that you're getting from that equation, those predicted values, are just not constant. Like they're not reliable, sort of say. And like what's another way of saying it? The difference, right, between your actual value and the predicted value is like a lot, either negative or positive. It's a lot, and it's not really close to zero, therefore it's not really the best line of fit. So really we're looking for no pattern and that the values are centered around zero, and obviously these have, like, they don't have those things. We see a curved pattern and the values are not centered around zero. Therefore I don't think this regression line is a good fit for the data. So no, because there is a pattern, right? There is a pattern, and values are not centered around zero, right? So that's the idea. Let's see what's next. Oh, kind of the important ideas. Okay. So what did they ask us? So scatterplot did that. Really the idea, it's the same thing. It's like, okay, the line, right, that we chose is the normal format is predicted y, or y hat, is equal to a plus bx, with a being your y-intercept and b being your slope. And then our whole thing was what? Negative 3,222 and so on. And so really what we're checking for, the question was, is this the best line to predict the iPhone 8? And we did that by checking the residuals. So the residual was actual minus predicted, right? And then we looked at a plot of residuals, which is, the line at zero. So this is the 0 is kind of like, you're looking at the differences. That's what the residual plot is. And so we're looking for, we kind of had this graph here, and we can clearly see like a curved pattern, which is like not the best. So this is like a no. But really, what a really good graph would look like for residual is if you just have, you know, this. This is a good graph because there's no pattern and the data is centered around 0. Meaning that your predictions are really close to the actual values from like previous data where you actually have the actual, number of iPhones sold. So that's kind of the idea. And then um, my little notes thing is, again, your actual value is greater than your predicted value if whoops, if your residual is positive, right? Or it's above the line, right, in a residual plot. And then your actual value is less than your predicted value if your residual is negative or it's below the line in your residual plot, right? And then what else? Oh, and for a good, right, again, a good residual plot means there's no pattern. And what else? It's centered around 0, the data. Um, Let me just add that there. So data centered around 0, and that's kind of the idea. All right, so yeah, that's kind of it. And then we never even got to predict how many iPhones will be sold in for the iPhone 8. So let me just look at the year that the iPhone 8 was released. What was it? 2017? Right. So here we go. I could just go ahead and change the year to 2017. Let me actually do 2017, run that, run that, run that. Um, we don't have the actual actually, so we don't really need the residual. This is inaccurate. Really, what we just need is the prediction. So the predicted, right, units sold or the units sold for iPhones in millions, the iPhone 8 is 14.6, let me just say 14.7 million. So the predicted, in other words, the predicted um number of or the predicted units sold in millions for the iPhone 8 is 14.6, no, 14.7 million iPhones. But again, we just proved that this is not really a good prediction because the regression line is so bad. Because again, if the data is not centered around 0 and there's a pattern, meaning that our values or our predicted values were just too far off, both in both directions, positive and negative. They were either too low or too high, from the actual values. But if you wanted to see the prediction based on this line, this is definitely not the least square regression line, but based on this line, that would have been the number of iPhones sold. Let's actually, oh, actually, no, I can't search it up because Apple stopped posting their sales data after the iPhone success. But yeah, that's kind of the idea. Just gonna move this back to 2007, just to kind of, do some closure because I really did want to know how many iPhones would be sold. But yeah, the idea here is, we can't use this line because it's not the best line of fits, and it's also not the least square regression line, which is kind of the same thing. So yeah, that's it for today. I'm gonna go now. Bye.